Hello friends, welcome back to my channel Fantastic Learntastic. Today in this video I'm going to be telling you how to derive the two laws of motion and the law of conservation of momentum from only one law, that is F is equal to ma. So I'm going to be telling you from F is equal to ma you can derive the first law of Newton, that is inertia, the third law of Newton, that is for every action there is a reaction, and the law of conservation of momentum. Okay, so this is a very nice trick to remember all the laws without actually memorizing them, and this is a very effective video, so don't forget to watch it. Right, so now we're going to be discussing how we can derive all the laws from the second law of motion. So first we need to understand and that force is the rate of change of momentum. This is a very important concept because of which this only we are going to be able to solve it. Force is the rate of change of momentum. So what does this mean? Force, that is net, I will not write net every time, but force is equals to delta P by delta T. Exactly. So now we are going to be understanding how to derive F is equal to ma from this. So delta P, so P is nothing but momentum, okay. So P is equal to mass into velocity. So we can write this as mv2 minus vm v1. Okay, one second. Okay, so mv1 by t, correct. So mass is constant, so assuming the mass to be constant, mass into v2 minus v1 the whole upon t. Yes, because we can take common from factorization. So now after this what we will do, we know that acceleration is equal to v2 minus v1 by t. So we are going to be substituting it, m into acceleration. So force is equal to mass into acceleration. This can be derived from this. So I hence proved you that force is equal to mass into acceleration. And this is the nothing but the second law of Newton. Okay, second law of motion. So now we are going to be discussing how to get the law of conservation of momentum. What does the law of conservation of momentum say? The law of conservation of momentum says that at any point of time in a particular system, uh, it would always be zero, right? So that is the law of conservation of momentum. What I'm basically trying to say, it's not going to be zero, it's going to be constant, right? So how to prove this? Again, let us take out our old formula, delta p by delta t. Now let us say, assuming the force to be zero, we are going to assume the force to be zero. So that means 0 is equal to delta p by delta t, correct. So time cannot be 0, hence we have proved that delta p will be equal to 0. And what does this mean? Delta p is nothing but the change of momentum. This is delta p. Delta p is the change in momentum. So if there is 0 change in momentum, the momentum is going to be constant. So let me repeat. What does the law of conservation of momentum say? The law of conservation of momentum, right? So what does this law actually say? This law says that momentum is going to be constant. Momentum at any given point of time is going to be constant. Constant matlab ki it is not going to change. So how do we show that it is not going to change? So we have our second law of Newton, second law of motion, force is equal to ma, and this is nothing but delta p by delta t, right? So if we assume the force to be 0. Let us say the force is 0. So when it is 0, what will it be? 0 equal to delta P by delta T, and time cannot be 0. So what does that mean? This means that P is equal to 0, something which I have written over here. P is equal to 0. And what is P? P is the change in momentum. So if there is no change in momentum, this means that the momentum is constant. So from this formula, the second law of motion, we got this, the law of conservation of momentum. So one task is complete, right? Alright, so our first objective was to prove that from F is equal to ma, we are going to prove that we are going to prove that the law of conservation of momentum is there. So in other way, our first objective was to derive the law of conservation of momentum from F is equal to ma. What is our second objective over here? Second objective is to derive the first law of Newton from F is equal to ma. So first let us write a couple down of things. F is equal to mass into acceleration. And what does the first law of Newton say? First law of Newton says that if a body is at rest, then it will continue to be in rest unless an external force is acting on the body. Or if a body is in motion, then it will continue to be in motion unless there is any external force. That is the first law of motion, also known as the law of inertia. So how will we prove that the law of inertia from F is equal to ma? Let me show you. So we first proved law of conservation of momentum from F is equal to ma. Now we're going to prove the first law of Newton. So law of inertia means that the acceleration is going to be 0. Why? Because if it is rest, then there is no acceleration, and because there is no acceleration, it is going to be in rest. But if it is in motion, then if there is no acceleration, or in this context minus a, or deceleration, if there is no deceleration, then it will not stop, it will continue to be in motion. So to prove the law of inertia, what we need is to prove that a is equal to 0. Alright, so while proving the law of conservation of momentum, we took the force to be 0, didn't we? So again we will take this to be 0. So mass into acceleration. So if this is equal to 0, that certainly means that either a is 0, m is 0, or both of them is 0. So what we need to prove? That a is 0. And why m is not 0? Mass cannot change in the entire universe. If you are on earth, if you are on moon, okay, the mass will never change, it will always remain constant, right? So mass cannot be 0. So what does this prove? That acceleration is equal to 0. And acceleration is 0, that means the first law of Newton is checked. The first law of Newton states that there is no acceleration, so a body at rest will be in rest, a body in motion will be in motion. So what did we do? From the second law of motion, we proved the first law. This was our second law, and this is our first law. Perfect. Now let us move on to the third law. So third law क्या कहता है? Third law ये कहता है that for every particular action there is an equal and opposite reaction on the two distinct bodies, right? Not like if I am applying if a horse is applying an action, like if a horse is pulling a cart, okay, then it's not that the horse is pulling the cart and so the cart will pull the horse with the same reaction. That is not what I'm trying to say. It is on two distinct bodies, right? On different bodies. That is what so some people usually say the third law is action for every action there is a reaction. They don't say the important part on two different bodies. So this is very important, that action and reaction are on two different bodies. So the horse is actually applying it on the ground, and that is why, and because he's applying it on the ground is pushing him. He's doing his action of pushing the ground is doing reaction of making him go forward. The horse is आगे बढ़ रहा है, and along with the horse the cart is also moving ahead. This also happens while we walk. While we walk, we push the ground then pushes us forward. We push the ground, that is action. The ground pushing us, that is the reaction. All right. So the horse and the cart are not action reaction. The ground and the horse are the action and reaction. All right. So let us take a system. What is a system? In a system is nothing but a defined space. It's okay. So this is all the forces outside. These are the external forces and all the forces inside. So if there is a system, एक सिस्टम है जिसमें दो बॉडी है, A and B. Alright, so in that system the forces between A and B is going to be neglected. Okay, only the external forces are to be taken into consideration. So I'm going to explain the third with a diagrammatically. So we have a system over here, body A, body B. So let us say the body B pushes A. So again, what is the law of conservation of momentum? You know this conservation of momentum. What does this say? That it will always be, the momentum will be constant. The momentum will be constant. So let us say that initially the two bodies, so okay, तो the momentum जो है वो हमेशा constant रहेगा. Unless and until external forces are not acting, it is going to be constant. Okay, so unless no external force, the momentum is going to be constant. This is what the law of conservation of momentum says. तो अभी इसका क्या मतलब हुआ कि अगर एक सिस्टम ऑफ बॉडी है जिसमें एक बॉडी A है और एक बॉडी B है, now both of them are at rest, and when they are at rest, momentum, okay, which is P is going to be 0. Rest में है, so the momentum is going to be 0, and since it is going to be constant after another 150 years also, it is going to be 0. Okay, so let us, but this is momentum and this is a system. So system, we consider only external forces and we neglect the external forces, internal forces, right? But we have to take into consideration. So let us say that in our system of A and B, right, the B pushes A. Now the P should always be 0. Okay, this is universal law. So if A pushes B, A will go into some velocity. A will start moving with some velocity. So B is here. Pehle A was here, now he's here. It has gained some velocity. Okay, x meter per second. Okay, so now what will happen because of this? P will not be equal to 0. What is P? P is mass into velocity. And if there is a change in velocity, that means the P will not be equal to 0. But what did we tell you earlier? Because it was at rest, P is equal to 0. Or एक बार P is equal to 0, it always has to be 0. And that is why, and that is the particular reason why when B will push A, not only A will move in this direction, B will also move in this direction. Why? So that there is this, so that it is still 0. तो ये आगे बढ़ा, यहाँ से यहाँ आ गया, but B भी यहाँ से यहाँ आ गया. So there was no distinct change, okay, and P was still equal to 0. क्योंकि ये आगे बढ़ा तो गलती सुधारने के लिए इसको भी पीछे जाना पड़ा, right? Tit for tat, and because of this P is equal to 0, and because of अभी P equal to 0 है, the law of conservation of momentum not violated. And this brings us to the third law. What is the third law of Newton? For every action, there is a reaction. So, B pushing A is an action. B pushing A is an action. And B going back is reaction. ओके सो ताकि P ज़ीरो रहे, A को पुश करने के बाद B पीछे चला गया ताकि P ज़ीरो रहे. And what does this tells us? For every action there is a reaction. Let us summarize it all. What did I just tell you? The second law of Newton of motion, F is equal to ma. From this I proved the first law where F is 0, so A is 0. So this proves the law of inertia. Okay, the third law I just explained. So the momentum is at 0. Why is the momentum should be 0? Because it was at rest. So the momentum को हमेशा 0 रहना है, and that is why for action there is going to be reaction. Okay, so this is the first, second and third law of Newton. One more thing I explained, the law of conservation of momentum. For the law of conservation of momentum, F is equal to delta P by delta T. F we took to be 0, time cannot be 0, so delta P is 0, and so the change of momentum is 0, and because there is no change in momentum, the P is constant. So just because now you are following fantastic, तो अभी आपको 3 laws नहीं याद करना है, आपको बस एक लॉ याद करना है. You only have to learn one law, that is F is equal to ma. Thank you very much. Don't forget to like and subscribe. So I hope you got how to manage them. Alright, don't forget to like and subscribe. I'm on Instagram also. Don't forget to like and follow me there. Bye.